How do you make sure the lights stay on when the sun isn't shining or the wind just isn't blowing? Well, today, we're going to look at a research team in Jordan that's using the power of pure math to solve one of renewable energy's biggest headaches.
Right, let's just jump straight into the big question. We all love the idea of solar and wind power, but they have a fundamental problem, right? The sources, well, they're not always on. So the real challenge for our entire clean energy future is this. How do we make them reliable, like 24/7 reliable?
Well, believe it or not, an answer is being worked on as we speak. Over at the University of Jordan, there's a super specialized team of researchers, and they are tackling this exact problem head-on. Now, their official name is the Mathematical Modeling of Renewable Energy Systems Research Group. I know, it's a bit of a mouthful, but their work gets right to the heart of making green energy something we can all depend on every single day.
So, what's the game plan? What are they really trying to achieve here? What's the core mission that drives all this research?
Officially, their mission is to advance the modeling, optimization, and control of renewable energy systems. Okay, let's be real, that's pretty academic. So let's break down what those three big words, modeling, optimization, and control, actually mean for you and me.
The first piece of the puzzle is mathematical modeling. It sounds complicated, but just think of it like this. They build a perfect digital twin, a virtual copy of a power grid on a computer. This lets them test everything, throw crazy scenarios at it, and perfect the design, all before anyone lays a single brick or spends a single dollar in the real world. It's an incredible way to innovate without the risk.
And this isn't just theory, not at all. Their work is laser-focused on the technologies that are going to power our future: solar, wind, and thermal energy. And maybe most importantly, the smart grid tech that we need to juggle all of it efficiently.
So you might be thinking, okay, how on earth do you build a digital copy of an entire energy system? I mean, that sounds insanely complex. Well, the secret is in their unique approach to solving problems.
See, here's the thing. This isn't the work of just one kind of scientist. Their real strength, their secret sauce, if you will, is that they bring together experts from a bunch of different, really smart fields.
And you can see that fusion right here. They start with the foundational language of applied math, then they bring in the practical, how to build it knowledge of engineering, ground it all in the fundamental laws of physics, and then they bring it all to life with the incredible power of computational science. Every single step is absolutely essential.
And it's this special blend of brainpower that lets them go way beyond the old way of doing things. It's what unlocks their ability to use some of the most powerful and frankly coolest techniques available today.
So what does that toolkit actually let them do? Well, we're talking about running these incredibly detailed simulations to see how a power grid would handle, say, a massive heat wave, or using AI to predict when clouds will cover a solar farm with mind-blowing accuracy. And they develop dynamic control strategies, which is just a fancy way of saying they build super smart automated systems that act like traffic controllers for electricity, redirecting power in milliseconds to keep everything perfectly balanced.
All of this technology is absolutely amazing. But, it doesn't just invent itself. So, who are the people behind the curtain? Who are the brilliant minds actually building these models?
This groundbreaking work is really powered by a team of deeply dedicated people. It's this fantastic mix of doctors with PhDs in super specialized fields and talented engineers who know how to take a brilliant idea and actually make it work in the real world.
And here they are. You've got this amazing combination of PhD-level researchers who live and breathe theory, working side by side with hands-on engineers. That blend of deep academic knowledge and practical, real-world skill, that's what makes their work so incredibly effective.
Okay, so we've got the methods, we've met the team, but let's bring it all home. In the real world, why does any of this actually matter to us?
What it all boils down to is this. They are building a bridge over that huge gap between theoretical science, the equations on a whiteboard, and the practical, on-the-ground stuff that actually keeps our lights on. They turn complex ideas into things that really work.
And you can see their contributions are super tangible. They're giving governments and companies the hard data they need to plan for a green future. They're creating practical, data-driven tools that power companies can actually use. And in the end, they're making our entire energy system stronger, more resilient, and ready for whatever comes next.
So when you just zoom out and look at the big picture, what this team in Jordan is really doing is paving the way for a future I think we all want to live in. A future where our energy isn't just cleaner and cheaper, but most importantly, a future where it's truly reliable for every single one of us.
And that kind of leaves us with this one last really fascinating thought to chew on.
As we're all searching for the answers to these huge energy challenges, could it be that the real blueprint for our sustainable future isn't being built with just steel and silicon, but it's actually being written in the elegant and powerful language of mathematics?